Hey everybody, so today we are in a different location than normal. I'm actually out in California filming something that I will talk about later this summer on the channel. But for today, we are going to be joined by a special guest who is going to talk to us about knowledge graph and AI, but from a highly regulated space. And this is something where you have a lot of different considerations that you have to think about that maybe you don't normally have to if you're not from that industry. So if you are interested in learning more about that, make sure you stick around.
Yeah, my name is Jacobus Geluk, but I always worked, at least always, like in the last, since 2010, when I started in a large bank in New York with semantic technology, and I've never left it alone. That's now my thing, full-time knowledge graphs, and at some point we started calling it, or I think I can even say I started calling it enterprise knowledge graph. So that's my main story basically. Like, what is an enterprise knowledge graph? What can you do with it? And especially nowadays, how uh, how important is it to have such a thing in your house to work with LLM? So
Mm-hmm.
I would even claim maybe during this call try to make that point. In order for Gen AI to work properly in an enterprise context, highly regulated, data-intensive environments, mission-critical use cases, I think many people are coming to the conclusion that you do need knowledge graph or enterprise knowledge graph
Yeah.
to make that work properly. So, and
Mm-hmm.
that's the main point that I would like to explain.
Nice. And I know we're going to dive into a lot more detail on this, but the thing that always comes to mind first when I hear that is what kind of knowledge graph? Is it a property graph? Is it an RDF graph? Is it both? Is it a little bit of
Yes.
each? What is it?
Yes, well, for many years have been a little bit religious about this. Like semantic knowledge graph is much more superior than a property graph. But I'm getting older, and it's not really that important anymore. We can agree to disagree, and it's perfectly fine if some parts of your enterprise knowledge graph are implemented as Neo4j graphs or Tiger graph or any of the property graphs that out there.
Hmm.
And actually, I think an enterprise knowledge graph is not so much about one type of database, because that's what the discussion often is. It's a discussion about what database do we use, a triple store, or do we use a property graph database? Um, and then there's a fight in the triple store side. You have Stardock and OntoText GraphDB and AdiFox and Lego Graph
Hmm.
Virtuoso. Let's name all the big ones. Because otherwise I
Hey,
get
you didn't mention Neptune, which is apparently
yeah,
both sides.
Neptune, of course. Neptune, how could I forget Neptune? And and then on the Neo4j, on the property, so the property graph
Hmm.
side, we have Neo4j and target graph especially. I don't really know that many other big ones there.
Oh,
Uh, NS
yeah.
graph, I guess. Yeah.
Yeah, Arango, I know is memgraph. Those two are
Uh,
kind of,
yeah. Yeah.
getting bigger.
Yes. 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 So
I
I
have a
think
whole series, if anyone's listening, on reviewing all of these tools. If you're interested in that on the channel, it's elsewhere. But that's the thing, like so many people get tied up in tool selection, and I almost feel like that is a red herring. It takes you down a path that is important, but not important in the stage I see people usually talking about it, which is right away. They don't start to talk about, what kind of data do we need to answer this use case or question?
yes.
How do we get at that information? How clean is it? And then how do we model it? Because
Yes.
whether you're using property graph or RDF, you still have to model it in some way. So that, and I mean, maybe, and that's, I actually want to ask you this. What are your thoughts on now GraphRack? It just fixes everything for you.
Well, I am already quite old. So I'm doing this. I'm in IT for more than 40 years, believe it or not. And that's and then you see all these waves of people
Mm.
believing in magic. That every time we have a new wave, and that's you have Hadoop and data lakes, or big data warehouses were once a big one of those waves, or yes, like so. Of course not. GraphRec is not going to solve all your problems overnight. It is a fundamental new thing, and maybe one of the biggest changes ever. But it will not. You cannot believe in magic in the sense that everything in all your problems will be solved by it. Like you still have to do a lot of homework and the homework that you need to do in order to make graph rec and LLM work is you have to explain. Like there's a lot of knowledge in the
Yeah.
heads of people, basically. Yeah,
Yeah.
so that knowledge needs to get out there before you
Hmm.
can. For example, I just had a discussion with an expert in ODRL. That's Josh Corneo.
Hmm.
He's brilliant, and and we were talking about this. If you want to see an agent, let's say an LLM agent, as a human, like doing work that normally is done by humans.
Hmm.
Well, humans and employees, they have lots of knowledge in that. You can kind of assume that they will do the right thing in most cases, and there are consequences if they don't do the right thing. So a human can be allowed to access certain systems
Hmm.
and do the right thing with those systems. But if you then give that work to an LLM, the LLM doesn't care, has no conscience, has no morals and values, etc. Has no consequences for it. Will not. You can't fire an LLM. So something needs to be done there. Like, and it's all
Yeah.
about context. Like, what is the use case? What is the business purpose that you want to achieve?
Hmm.
What are all the controls and the regulations around it? How do you deal with PII data? All those things that are in the heads of people
Hmm.
need to be captured somewhere. And that is so complex that it's not something you can just put in an Oracle table. That's where a knowledge graph comes in. It's that it's with a knowledge graph, especially a semantic knowledge graph, I would argue, but with any knowledge graph, you can model much more complex data basically, and that knowledge needs to be captured somewhere. And I would even say, even the LLM can produce a lot of data, but what do you do with that data? Like, is that
Well, and
data?
does it make sense for your context, right? Like I know
Yeah,
that there's a lot of people that talk about that when it comes to the neurosymbolic AI, where you have the AI and you have the knowledge graph, working together. A big part of it is, well, how do you define customer? And under what instances is someone a customer versus a vendor? And like, all
yeah,
of these little things that sound easy to do and this is the part that I always emphasize, is it's not even about getting it into the graph or getting the AI to understand it. Yes, those are also things you got to worry about, but how do you and I agree on it? Like the age-old problem. Like we
yes.
have to agree on how we're
Well,
defining some of these things before anybody else can use it.
yeah, well, you say have to, right? Let's focus on that one. Like, you have to agree before you can do things. So that is something I hear all the time, and that is, I would say, most systems that you have nowadays, or let's say all systems that you have nowadays, are kind of single version of the truth systems.
Yeah.
And they're in their context. There's basically one context, a siloed system,
Hmm.
where the designers of that system, the data modelers and the architects, etc., they say, okay, this is our version of the truth. We call a customer a party instead of a customer, or a patient instead of a customer. There's all kinds of context where another term makes sense, basically. This is how we think the world works, and this is our single version of the truth. And now we're going to try all our people around us, all in other departments, to use our version of the truth.
Oh, see, I don't agree with that. I don't think that's even possible.
No,
That.
that's not how the real world works, and that's
No, it
why
does
large
not. Yeah.
enterprises have some. I work currently for a large bank, and they have I don't know tens of thousands of systems.
Mm.
Like I know other banks, I can name those names. Like for example, HSBC. I heard someone say they have 40,000 systems. I think JP Morgan has even more.
That's so
So
sad.
that's and each system has its own version of the
Yeah.
truth. And then you
Yeah.
can try at a central level. And there's whole departments. There's the central data offices. The
Yeah.
chief. I heard one keynote speech from a CDO. Basically, it started saying, "My mission in life is to create a single version of the truth." I said, "Well, good luck with that."
Yeah. Yeah.
That's
Find
not.
two humans that agree on everything. I mean,
Yes.
I guess my comment is always more about, and maybe this is my own biases of the type of projects that I've been on, is legacy systems. So yeah, I mean, if you're having a project, a data transformation project, and you're trying to get, I don't know, even two departments to agree on what is a customer, yeah, they're each going to have their own definition of it. But often, and also, I know you're working in, some regulated markets like banking and other things, whereas a lot of the markets I've worked in are not as heavily regulated. Maybe they should be, but they're not.
Yeah.
And so they are not even at that stage. Like even their own department, I just did a video a week or two ago, I think, where I was looking at a taxonomy project that I was doing with the Smithsonian, and they have artist as a node. And it's like, okay, so artist, is that the artist that created it? Is it the artist that used that to then depict something else? Like there's all these like different
Yeah.
depths of knowledge within that one node. And it's a legacy thing that somebody created. So we don't know. We're going to have to make an interpretation on what that's actually used for. And then if you look at the actual data, you can see that it's kind of a muddy mess on what actually is artist. What does that actually mean from a data perspective? So that's usually what I mean when I'm talking about this is like it's hard enough to get everyone to agree to things when you're doing something new, like you're talking about. But oftentimes, most people don't even know what their own data today, right now, is defined as. And then they have to try to figure that out.
It is a data mess everywhere, not a mesh, but a mess. Like all data practitioners would agree with that. Okay, if you call it customer name, then I can call it customer legal name or something. But then we can make that translation at least. We can do the mapping,
Mhm.
so we can work together.
Yeah, it's the
But
graph of graphs, right? Like and you don't need everything in one graph. Like that's the other thing I hear a lot of people talk about with this same principle, which is, oh, great, now we're going to do the knowledge graph thing, and everything has to be in the knowledge graph, all one. Like, well,
well,
you.
yes. So for me, a simple way to say the difference between a knowledge graph and an enterprise knowledge graph is that in a knowledge graph context, you basically people kind of think almost like it's one database. It's one giant Stardock database or GraphDB
Mhm.
database. I'm not going to name all those names again, but it could be any of these databases. Whereas an enterprise knowledge graph is not something that lives in a database necessarily. It's more like a virtual thing. It only lives at query time, basically. Like you,
Mhm.
you call an API that gives you one part of that graph, and that graph can be constructed on the
Mhm.
fly from many different sources. Like that could be a triple store or a
Mhm.
Neo or Oracle or whatever. You
Mhm.
can construct that little piece of the graph that you asked for at query time, right? Or update time. So it's a service layer in that sense.
Yeah, but where do you see this fitting in now when we have the agentic search, right? Where you have an AI that kind of helps you determine where all that data is. I mean, from a query time perspective, right? So you do the query and then it knows enough about your data in its disparate sources that it can go in and get what you need in a more efficient manner.
Well, that's what
Promise.
I see that many colleagues are doing. Like, so the LLM can generate Sparkle statements or SQL statements or whatever. Let's use the LLM to connect to multiple endpoints, multiple databases, and get me the answers that I want. To me, that sounds ridiculous, and especially in an enterprise, a highly regulated enterprise environment. It's a nightmare scenario, I would
Mhm.
say. It's not going to happen in production. It only happens maybe in a silo, but I don't
Mhm.
want a new silo. You can maybe say I have one LLM RAG system that has a that has connected to a limited number of data sources, and it goes and it generates your Spark or SQL statement. But that's still only a silo then. But if you really want an LLM to be like a human, to be able to think across your whole landscape of information, even more than a human can do, an LLM could literally come up with answers that you, as a human, never think of potentially. And that and giving that LLM then access to all your database endpoints or all your APIs, that's just a fantasy dream. That's not going to happen. That's
Well,
impossible.
that's what I mean. It's a promise a lot of people are trying to make. Well, one
Yes.
thing I want to ask you, because again, I think it is very particular to highly regulated spaces like you're talking about, where if you're doing something across the multiple places that you have research on the open web, there's nothing wrong with doing agentic search because you know which databases they
But
are. There's
that's
no
public data. Yeah.
regulation. Yeah.
No, you can do whatever you want on Google. Yeah, that's
Right. So I guess what I'm asking is if you could explain to the audience who may not be as familiar with your space and what does it mean? Why is it a nightmare when you're in a regulated space to have an agent be able to access that data?
yes, but it's like so. So I have a solution for this problem. We can come later on that. But why is it? Why would it be a problem? It's like there's multiple aspects to it. Like there's a technical aspect because LLMs can make mistakes and can generate queries that might actually be so heavy that they can bring down your system. That
Hmm. Hmm.
create so much load. That your availability of your system can become in danger
Hmm.
because you
Hmm.
don't know in advance what type of queries are coming to your system. So that's the technical concern that many system owners will have. So they will be scared of that basically.
Hmm. Well, because there's a cost to that too. It's not just it
Cost
goes
of that,
down, but there's a
yes,
cost to that.
yes, and theoretically, like or in practice even, I've seen situations where some queries can bring down the system
Hmm.
crash even.
Hmm.
So
I've seen it happen too. It's
yes,
real.
so that's not that not. Then you have yeah the security side of things. Often the security is not just done in the database, but in the application layer above that. So if you bypass that application layer, go straight to the database, then you bypass all the security.
Hmm.
You could see tables that are not for you to see.
Hmm. Hmm. Hmm.
Um, then an LLM, is the LLM actually operating with your user ID or with a generic user ID? So
Hmm.
you as a person would never be able to see the data, but is the LLM able to pull data out of the data that you then get,
Yeah.
basically?
Well, there's
That's a,
traceability problems even with that too, right? If it makes up a generic ID, then you can't
that's
track
a
where it's been.
security problem. So
Hmm.
yes, if the LLM would log in to all these database endpoints with your user ID on your behalf, like you can do that with Kerberos or with cookies or
Hmm.
like
Hmm.
maybe KWT cookies, etc. You can do all that, the technologies for that, but not all database systems really support it properly, especially not the older ones.
Hmm. Hmm.
That's just technical reasons.
Hmm.
But you also have all the regulatory reasons, yeah, for example, in large banks, you have these Chinese walls between departments. So, like, if you're on this side of the wall, then you're not
Can't talk
allowed
to
to.
the other side. Yep.
Yes. There's also things like if you have a bank account in South Korea, then you cannot just copy that data to another country. Like there's thousands of
Hmm.
regulations.
Hmm.
Every country has their own regulations, basically.
Hmm.
So yes, all those systems are connected in one giant network in large enterprises, but that doesn't mean that you can just pull data from any place
Yeah.
by some LM in some country. Basically,
I
that's
think a
not.
lot of this boils down to the fact that I've seen a lot of it's almost too easy to use AI. for a lot of things because it's so easily accessible now that
Yes.
I've noticed not enough people are asking. It's like just because you can doesn't mean you should, right?
No, no. In fact, and maybe it helps to think about it. Like an LLM is kind of an extension of a human. Like
Mhm.
it works on behalf of a human. Would a human be allowed to do it? If the answer is no, then it's probably also not allowed for the LLM to do it.
Well,
That's
yeah, and humans can get corrupted just like right? Like
yes,
I like a lot of people are thinking, well, the AI is more susceptible to fraud and prompt injection and all these other things, but yes, but also so are humans. It's not like humans are infallible as well.
true. But at least humans have to bear the consequences of their
Yes.
behavior,
Yeah.
and LLMs do not. So
Very
that's
true. Very
a
true.
difference. So and an LLM is innocent. That is like it will
Yeah,
just
it's just programming.
yeah, it will just do what the best solution is. And if that means that you have to pull some data that you're not allowed to see out of some table, then it will do that because it
Yeah.
will just reason
Well, and
this is
there's
what
also
we want.
that other issue where again, I think it's sometimes lost on folks that aren't as familiar with how LLMs work. It's not just normal regular AI, like a BERT model I would consider is like just traditional AI.
Yeah,
Uh, but when you're talking about these large language models, it's usually a core model or models that are controlled by whoever makes that LLM. And again, if it's an open LLM, you can have a local copy and all of those good things. But if you are using one of the big third party ones, you have to be really cautious what you're exposing to that LLM because if you don't have the proper precautions in place and guardrails, that information could go into the big AI brain and then you can't get it back out.
yeah.
You can't unlearn it.
No, yes. So you cannot train your AI on all the data of your organization. That's you cannot just put it all in one place and
Hmm.
let it do its thing. That's So only the generic, basically only the public data, or the, let's say, the
Yeah.
internal use only data, that which is not the confidential data or the PII data.
Hmm. Hmm.
So let's say the generic data like policy documents, etc. Okay, fine. That's every employee in the organization can see that anyway. So let's train the LLM with that. Fine, but not specific customer records, for example.
Hmm.
That kind of stuff, of course, is not part. So the LLM agent will have to communicate with all these backend systems
Yeah.
to do its job. And for that, I think you need knowledge graph to make that, to streamline that, to create the guardrails around it. And
Hmm.
one major point I would like to make is in that sense is context. It's like what is the context? And context nowadays, so far, is captured in the heads of people and in hard-coded software programs.
Hmm.
They know about the context. But if you have a much more open, you break that all open basically. So now it's not just humans. We now also have LLM agents. Let's say you can call them virtual employees or virtual colleagues.
Mm.
So every person working in the enterprise gets their own team of virtual employees that do stuff for that person. So that will be a model that could work, I think. So in order to do my work, I start up a whole bunch of agents doing all kinds of all the tedious work.
Hmm. The tedious low security
Yes, for
risk.
example, every week I have to fill in my time because I'm a contractor. Usually, I have to fill in my time registration in multiple systems, sometimes even, and it's tedious. I hate it, and I'm always late. I would be very happy if I can just have an agent say, "Can you please take care of that?" Like you know my calendar, you know when I was at the office and when not. I don't want to fill in 8 hours 5 times a week
Yeah.
all the time, basically. So okay, there's an agent for that. Can
Well,
have
an
another.
argument that I've heard against things like that, and I'm not saying I'm on one side of the argument or another, but it's
there's such a heavy social and environmental cost to the AI running. Is it worth using it on things like that? I mean, it does free up your time for sure. And then you can maybe go on and, solve world hunger if you have more time on your hands. So there's, it's always a cost benefit analysis. It's a trade-off. But I have
Yes.
heard some folks push back on that to say like, okay, yeah, but like is the full cost of using the AI on something like that worth it? And I don't know the answer to that, but I'm
No.
curious if you've heard that too.
No, yeah, cost is always a factor, of course. Someone has to pay the bill of the AI. But so I think there are use cases that are give so much benefit. For example, you could figure out what is the actual state of your technology landscape. Try to because I've worked now for multiple large enterprises where that was a problem. It's always a problem, actually. It's if you have thousands of systems, then those systems are all connected through ETL, through data warehouses, etc. There's data flowing from place to place. And we often call that lineage. We want to know what the lineage is,
Mhm.
not only just to understand all your dependencies, but also for regulatory reasons. Like the regulators are asking for that lineage. They
Mhm.
want to know
Mhm.
if, for example, I used to work for a large bank that was too big to fail, and there's a regulation called SR14 in the US. And that's kind of the living will, like for a bank. Like if you're too big to fail, then how can we break you up when necessary, basically?
Mhm.
So what are the let's say what is critical, basically. What
Mhm.
are the critical people, the critical systems, the critical operations, etc. Because how do you it's kind of a dependency
Yep.
graph, and that
Yep.
it's a graph problem.
Yep.
um,
I mean, it's the opposite of a supply chain bottleneck, right? You're
yes,
trying to find the critical pieces.
there's dependencies on all kinds of levels, dependencies on and data centers, how they depend on each other, networks, data flows, software components. It's like a layered cake of a
Mhm.
huge amount of layers of all kinds of dependencies. Those dependencies should be maintained somewhere, but unfortunately are usually not maintained
Nope.
very well,
Nope.
if
That
at
is for
all.
sure.
I used to have a work for a large company where they had thousands of systems, and they thought, okay, maybe we estimate that we can switch off 500 of those systems, but we don't know which ones, and we don't know what would happen if we do switch them
Oh
off.
yeah, that's an age-old question. Don't touch
Yes.
that system. We don't know what it touches.
Yes. So you're running all these systems, and you know that they are probably not even necessary anymore, but no one dares to touch them. So how much does that cost, basically? So if you would
Yeah.
have an LLM, and you give the LLM access to a number of sources, can you figure out by checking all kinds of little details what a human is too lazy to do that, basically. They don't want to do it. It's too expensive, even if you
Mm.
let humans do it, and too many mistakes. So let's check all these dependencies. Let's check the log files. Let's check the data elements that go back and forth. What is the lineage? What is the provenance? What are the network? What is going on the network?
What's
What are
interesting
the
is the
software
thing that you're
components, etc.
describing, the thing you're describing now, while it was not as effective as it can be now, because we have LLMs to help and they can do, you have feedback models, you have, all these other things that go into it that make it effective for this. But digital twins, what you're describing, right? Like you wouldn't want to do that in your live systems, right?
No.
Figure out, okay, if I switch this off, what happens? Right? You don't want to actually have it switch off. So, like digital twins, I feel like nobody really talks about them too much anymore, but like that's a lot of this is
That's
like
it.
trying to figure it out in cyberspace before you do it in real life.
An EKG is basically a digital twin, yes. And often we are modeling the data landscape and the technology landscape first, because
Mm,
if then you know how does your house look like, basically. It's like
yeah.
what do you have, like what are your systems, where is the data, what are your data products? That's another topic we could discuss
Mhm.
on the call maybe, but Let's say, I initiated the data product work group in the Enterprise Knowledge Graph Foundation. That's on the part of the object management group, a standards organization, and recently came out with the DPROD ontology, or the data product ontology, that describes your data sources like as data products. Basically, you want to think of it as you have a data economy. Your whole enterprise is, let's say, a data economy with all your thousands of systems. And then beyond the enterprise, with all your customers and partners and suppliers, you have lots of more data sources. They have data products too. You have data vendors like Bloomberg, for example, selling data, or London Stock Exchange Group. And there's like many companies sell data too. And you can basically put them all in, wrap them all up like nice data products. That is good for the LLM as well. Like you can then
True.
explain to the LLM, this is what my data is, this is what I have to offer, and these are the terms and conditions. Like, because it costs money to access data, etc.
And which parts of those data sets are the most useful? I mean, I think sometimes you get into these situations where you're too scared to not have it, just in
Yeah.
case. But I think especially with the cost of things now, especially housing a lot of it and doing queries across all of it, you're driving your latency up, you're adding cost when I think a lot of folks are switching to a just in time instead of just in case model, where you keep things just in cold storage. It's just kind of dumped somewhere, and then you can at least like query it up when you need it, not necessarily, when you're trying to do any particular query. But one thing I wanted to ask, we're talking a whole lot about where enterprise knowledge the knowledge graph, specifically semantic knowledge graph, would be very helpful. But I'm curious, for those that are not as familiar with this space, what are the key characteristics of what you define as a semantic enterprise knowledge graph that helps with some of the things we've been talking about?
Well, these 10 principles of the Enterprise Knowledge Graph Foundation, sorry, it's not foundation anymore. We merged with the OMG. It's now called Enterprise Knowledge Graph Forum. But go to principles.ekgf.org and you will see the 10 principles. If you check all those boxes, then you have an EKG, let's say. But it starts with the most obvious ones, like you have to have a strategy for identifiers. You have to have a strategy for meaning resolution. But a few others come to mind as well. For example, everything has to be related to a business use case. So anything in your landscape, like, you need to be able to point at the smallest atomic level detail and explain who owns it, what purpose does it serve, what is the use case, basically. So to come back to the data product side, like in an enterprise knowledge graph, you have your data products, but that's the supply side of information, basically. But on the demand side, you have to have use cases defined as use cases. And that's often left out. There's no, like, people love to talk about data, especially data people. It's like, oh, a lot of data, and we model the world, and it's kind of a little bit of a boil the ocean exercise. You can model yourself silly. But at the end of the day, you have a customer, some business department, some manager with a budget, and they are not patient, and they have limited budget, and they want to solve a problem. And so far, that means put a team together for half a year or a couple of years, even sometimes, and build yet another silo. That's why we end up with 40,000 systems
Yep, that sounds about right.
yes. And after when the budget is out, all those people disappear. They're often contractors. They never come back even. All the knowledge is gone. So you have now this thing in the house, some black box thing that works there, but and often has a life cycle of more than 10 years, or sometimes 20, 30 years, 40 years. There's literally systems are working that are made in the last century, basically.
Yeah.
So and no one really knows how to deal with them anymore or dares to change them because they don't know
I call those
Any,
the zombie systems. They're alive, but like kind of, and they're also
yes,
kind of dead, and nobody really understands them.
yes. Yeah, I used to work for a bank in New York who they called it you have the green field and you have the brown field.
Mm.
And so all these brown field systems, they needed to go. And we are now lifting and shifting systems to the green field, which was the cloud. But
Yeah,
then,
lift and shifts, they sound nice.
yeah, but then you end up moving very ugly brown field systems into that green field, and that green field becomes brown very quickly itself. And so that,
Die, wither.
yeah.
Yeah.
So we want to kind of escape from that a little bit, and try to make things a little bit better in that sense. So yeah, it would be good to just know, get that landscape in place, that you have
Mm.
that picture for, okay, where are my systems? What are they for? What are they serve? What are the use cases? Who's paying for these use cases? What business capabilities do they serve? You create a use case tree with business capabilities. It's all organized. We know what things are for without talking about the technology. Like the use
Mhm.
case defines the business need, does not define how it's implemented and which system is doing it, etc.
Yeah.
It defines the business need not in an Excel or a PowerPoint or whatever, but it defines it as very precise data in the
Because
graph.
that helps you make decisions, right? Like when you're talking
Yes,
about the green field, if you have that model that serves those use cases that you need for your business and there's KPIs, why do you
yes,
need that? That's funding usually everything you're doing.
yes,
Then you can get the data that you need to then populate it and not worry about the other stuff. And you're not going to bring in the withering pieces to your green
yes.
field.
And then you can slowly make a strategy for the most important use cases. We're going to lift them up to a newer architectures, microservices in the cloud, and like pay-as-you-go models. We don't pay anything when we don't use it. Like it's elastically scalable. Like we design it in a whole new way, basically, instead of keep dragging along, keep walking
But
with
all of our
around with
systems
the old
know that
system.
schema. Why would we change it?
Well, yes, exactly. So,
That's always what I get.
and if you even talk about the duplication of things, because your data is not in one place at all. Your data is copied all over the place. People don't even know how much.
Yeah,
Like
it's tough.
it's it's massive the amount of data that is being copied all the time and sits in the wrong schemas, and
Yeah.
the mess is just mind-boggling in many cases. So but you have to start somewhere basically, and don't think that the LLM is going to solve that,
Yeah.
so
Yeah, garbage
what
in, garbage out. If you think that the LLM is going to magically figure it all out for you, I
yeah,
mean, going back to your analogy, if you wouldn't trust a human just to sit down and be able to do it, chances are you shouldn't probably trust an AI just to do it on its own too. I
yeah,
think the same principle applies to this is do you think one individual would be able to sit down and figure all of this out magically, or would they have to do a lot of hard work, a lot of conversations, digging in, troubleshooting, like all of these other things that while AI is a good tool that you can use in all of
yes,
that, it's not going to solve it for you.
no, no, but if you have those use cases and they are defined and described in a very precise manner, and this is where we stand today, and in 2 years down the road we want to be there. Then you can eventually ask the LLM, can you generate that new version, basically? Can you generate all those microservices, all these little stories, all these little units of work that make up that backend, at least? Or can you also generate the front end for this? That already happens, actually.
Hmm.
It's like LLM. I mean that I'm a programmer. Like I program every day in programming languages like Rust and C++ and Python and you name it. I've done them all basically. I know what programming is, and I am pretty sure that we don't really need many programmers anymore. That it is mind-boggling good already what LLMs can do for you. So a big time when I work on my own machine, basically, then I can just talk to the LLM
Mm-hmm.
instead of actually coding it myself.
Yeah, I hear a lot of people talking about that. I mean, even, I'm going through this right now. This exercise is, do I teach these folks how to do Sparkle queries, or do I just teach them how to prompt the AI to do it and then troubleshoot it? Because I mean, it's not always accurate, but that sounds more sustainable because they're not going to be, again, if they were going to become ontologists or knowledge engineers and they're going to do this every single day, yes, they need to know how to do that by hand. But if you're a business
even
person,
that, even that, like an ontology, I've seen LLM generate ontologies that are pretty good. Like the
oh,
most
for sure. Yeah. I mean, you still do. I mean, just like we're talking about, the LLM is not magical. You still need to go in and make sure that it's
You
accurate
need to know
to
what you
what
want. You still need to have a kind of an
exactly.
architectural
Exactly.
mind if you want to create software or be a data modeler
Mhm.
in mind to say, okay, this is good or not. Like someone has to say that.
Exactly. Exactly. Well, I know that, we've covered quite a few topics going through all of this, and I think it's pretty apparent that there are so many different applications where an enterprise knowledge graph is going to help when you're experiencing things with AI, because the AI on its own is, it could go off the rails very quickly. So having
Yep.
those business rules, the data governance, all the things that encapsulate what is in a knowledge graph is really helpful. But in closing remarks, what are some of the things that you want to make sure the audience walks away with?
Well, yes, what is most exciting for me now is that I now can see in front of me how an LLM can be made effective in production, doing real hard work with using that use case idea. Basically, use case. It's all about context, basically.
Hmm.
And so use
Hmm.
case is that's the new context. We describe what do you want, what is the budget, for example, what are the things that you can access and not for this particular use case. The LLM is then allowed to call your stories in the use case, let's say, which then reach out to whatever data source is necessary, but with all the controls in place,
Hmm.
in a safe way. So and that works.
Hmm.
I've actually done that, and we can do these things now in production. So because that if we can scale this up, and I think we can scale this up,
Hmm.
that would really mean a massive change because there's so many roles. And I'm not saying this is going to cost jobs because it will basically make the increase quality and make people much more productive
Yeah.
in a drastic way. But all the tedious work can be delegated to LLMs in this way.
Yeah. I mean, that's I'm a supporter to, just like anything else, AI as a tool. Would you use a rock to build your house and hammer the nails in, or would you actually use a hammer? One
Yeah.
is going to be more effective than the other, and it lets you have more time to do the things that humans are good at, right? And
Yes.
so that's kind of where I'm at is, those that talk about AI as like this super smart, super scary thing that's going to take over the world. I mean, I think it's going to take over the world in a very specific manner, meaning more and more people are going to use it, right?
Well,
It's not going to take over as in like, robots are controlling everything.
everyone will be affected. Everything will be affected by this in the professional world, for sure. But we don't know yet how. But I think it could actually be quite a positive change.
Yeah, and I mean you do hear all of these other stories about how, AI has been used to help, identify cancer cells faster, or, there's all
Yeah.
these, things that just benefit humans in a very positive way. So there's that. And even the things you're talking about, right? Like banking and security and making sure things are tightened up and buttoned up to be appropriate and following the regulations that are there for safety reasons and whatever other reasons people think that these exist. All of those are still incredibly important, and AI can help with some of those things.
Yes, yeah, you
Yeah.
can make life better for people. You get your mortgage in 5 seconds instead of 5 months. Yeah, that's I don't know what the effects will be, but things will go. It will become much more productive.
All right, and I want to thank our special guest for joining us today. And again, if you're interested in sharing your story, how you got into Graph, what you focus on, what your origin stories are, make sure you reach out, because I'm starting a sneaky little thing. It's not going to be so sneaky for very long. I'm going to start to talk about it a little bit more. But if you are interested in sharing your story, make sure you reach out. All right, so with that, I want to thank you very much, and I'll catch you next time.